Recording in. All right, so I can see the volume moving there, and it's recording. So let me just share the screen. Okay. All right, so we're sharing now. So let's go ahead and start this last script. So as you might imagine, there will be some similarities, all right, between previous ones, but I'll start it from scratch. So let's open up the terminal here. We'll do bash. And activate PyTorch. I36. And today we're going to need to install some libraries. And then let's navigate to the desktop. Okay. So I have a data. All right, so this script, you will find it in my GitHub under PyTorch, deep learning, and then MLP for multi-layer perceptron. So if you go there, you're going to find 3 scripts: simple neural net, which is what we did last week. And then there's 2 in there now, CIFAR10 and cross entropy CIFAR10. So we're going to look at just CIFAR10. So cross entropy is basically just taking this one CIFAR10 and modifying it to include finally the optimized the loss function basically that you use for classification, the classic function. But before that, we're going to look at various other ways of doing it. Okay. So we're going to play with it a little bit, play with the code. As I said, this will be more of an exercise. You guys can help me out because it's fairly long. This one's fairly long and detailed, and there's some complexity in it. So one of the things that when it comes to machine learning, right? So over the years, it used to be that they built only the model. They only built the modeling part, right? So only creating the architecture for the neural network. And as far as the data set was concerned, you were kind of on your own. You had to figure it out. You had to do that all on your own based on your coding skills efficiently. And I kind of like that. And I kind of did it that way for many years, right? So I'm now in a situation where I prefer that. I've gotten used to something. But things have changed over time. I mean, things do change. And now both TensorFlow and PyTorch have decided not only do we give you the modeling part, we also give you the data handling part, what is referred to sometimes as data wrangling, right? That's the funny term or whatever, but actually people use that because wrangling the data, right? Like wrangling cattle or whatever, it's a tough job, right? So they've provided a lot of tools for it nowadays, okay? And so today I'll show you guys some of these tools. I still prefer to do everything kind of on my own from scratch, as I know it, I guess. But I will say a lot of these tools are pretty efficient. Okay, so they're pretty efficient. So we'll see how they work and get a sense for them. As I said, these are kinds of things that are very new. I mean, the last 2 years at most, right? And they keep changing. You're in an area that it's incredible for me. I started in 2015, at the end of 2015 with deep learning, when these libraries first became available, TensorFlow by Google. And in the last 5-6 years, the changes are just massive. Okay, and they're going to continue to change. So just be prepared for that. Okay, be prepared for all those changes. So anyway, we'll go over this. So let's get started then. So let me do clear. Let's just create a script. And let's call it CIFAR underscore NN .py. Okay, so CIFAR10 is a data set actually. All right, I think you call it CIFAR. I've never actually heard anyone use the word, so I'm always unsure when I haven't heard a word before. But CIFAR or CIFAR, whatever, is a data set. 10 is just the fact that it's a really large data set, and then they took 10% of it and created this subset for academic purposes. Now, it used to be, guys in the back, it used to be that you had to use MNIST, for instance. So you probably, if you've ever heard of machine learning, you thought, okay, where's MNIST, where's IRIS, why aren't you showing us that? And the reason is that CIFAR is a little bit more advanced than MNIST. It's very similar. So somebody just said, let's make it like MNIST, but a more complex data set. All right, so this one will be a little bit more complex. It's going to be, for instance, MNIST is only black and white images. This is going to be color images. Okay, so this is going to be color images. So let's open up the script here, and we'll have to install some things, but let's say this is the CIFAR10 image data set. And we'll actually probably take a look at some of the pictures. I think there are pictures of automobiles and airplanes and probably some birds and buses and things like that. So it's supposed to be whereas MNIST is more, it's a 7 and all 7s kind of look alike, right? But we all write 7, we all recognize it's a 7, but there's a slight variation in our handwriting, right? With CIFAR, it's a different problem altogether because, an automobile is not an airplane, right? Or a bird, or, whatever. So it's a more of a semantic understanding kind of a thing. Obviously, there's color, so, that's very useful. An airplane is usually in the sky, right? So it's blue in the background versus, I don't know, a dog, grass is green or something. So the color here is pretty important. So basically, CIFAR10 that's the data set. We're going to be dealing with, guys, neural nets, and in particular, deep learning, right? So this time around, we should be able to create a deep neural network. So we had the class last Monday. Hopefully you had time to review all that, practice. That's what I expect you to do, right? Kind of memorize those exercises. And then, because we're just building up on top of that. All right, and so that's what we're going to be building as part of the modeling. So let's talk a little bit about CIFAR. So CIFAR consists of 60,000 well, I guess I should say of 60,000 images. Okay, and they're very tiny images, so they're not the kind of images that you would enjoy looking at, right? Because it's actually, the images are pretty small that you can barely make out what's there. But as it turns out, even though we believe, we're led to believe that, ooh, AI is just around the corner, right? And that deep learning is revolutionizing the world, and it is. So we have this false understanding, I guess, that, wow, you can take a 4K image and give it to a computer or millions and it's going to learn. And that's not true, actually. The computational power that we have today with GPUs, with the most powerful GPUs, if we're really training with a large million type of data set, only allows images of about 300 by 300. If you think about it, that's pretty tiny. I mean, that's not very high resolution. If we have very high resolution images, believe it or not, we have to downsample them. We have to reduce the resolution to 300 by 300. I promise you, try to do this with one GPU, the most powerful RTX 2080 or whatever the the highest is now from NVIDIA. It's going to run out of memory. Deep learning is you've seen it. I've talked about it at least, that it's millions of parameters, and it's literally going to run out of memory. We've tried this experiment with our students here, and 300 by 300 is the maximum. And if you go to the literature, it's the maximum. You go to GitHub or Reddit or whatever, it's the maximum. All right, so there are limits actually, even in the hardware that we have has made all of this possible since 2007, but actually it's not enough yet. Right, so imagine how much. However, NVIDIA, a lot of people are saying that NVIDIA will actually drive innovation, and I think it's true of AI in general. They're the ones that will drive the innovation, because you can create all the algorithms that you want, but if you don't have the hardware, you're not going to get anything done. So we're kind of throttled, if you will, by that NVIDIA advancements. Does that make sense? All right. So anyway, so that's a very important thing for you to understand, I think, because people get the wrong impression that images, oh, we can do anything with images. Well, you can do within a certain scope, but in a general sense, you have to downsample the images to about 300 by 300. If you try anything that's like 500 by 500, you're going to start getting errors, okay? Even if you're using GPUs in parallel, because there are limits at some point in the RAM memory. Okay. All right, anyway, so the images here are pretty tiny. So it's tiny images that are 32 by 32. And they are in color, RGB. All right, so that's an important one. So remember that PyTorch actually expects a specific order in the way that we get images, right? So our images, if we want to display them, probably need to be, I think, height, width, channel, if we want to show them, which is the standard. But for whatever reason, PyTorch actually takes channel height, width. It's just the convention. All right, CIFAR is very much like MNIST. If you notice, MNIST has 70,000, of which 60,000 are for training, 10,000 are for testing, right? Or what they call validation. The same is true here. CIFAR has 60,000 images that we can use for training. The images in MNIST are 28 by 28. These are 32 by 32. Okay, and the reason probably is that with MNIST, 28 by 28 is pretty obvious. It's a 7, But with a full-scale picture of a bus or a bird or whatever, 28 and 28 may not be great. So they had to make it a little bit bigger to 32 by 32. But that's still pretty small. We will take a look at those images in a sec. All right. All right. The other thing is, it is a labeled data set, very much like MNIST, which has 10 labels for the 10 digits. This also has 10 classes. All right, so CIFAR has 10 classes, and they're digital numbers. I think they go from 1 to 10, if I'm not mistaken. We can see that. So from 1 to 10. All right, and so now that brings actually a bit of a problem, because do we want to do a binary classifier, or do we want to do a multi-class classifier? So what that means is a binary classifier is one where you just have 2 classes, right? Cat, dog, happy, sad, something like that. Multi-class is, well, bus, airplane, automobile, cat, which one is, right? So, and those are actually a little bit different. So we, especially when we're dealing with the optimization function, do we want what is called binary cross entropy versus multi-class cross entropy? We have to actually select one of the two for this type of problem. So just keep that in mind, because sometimes you might encounter some code and you think, oh, I'm going to use this code, but actually that code is binary, not multi-class, or the other way around. So you have to always be aware of it. In our case, for our example, just for simplification, we'll probably just start up with binary, which basically means that we have to select 2 classes, and so we'll just pick a few. We'll subsample, I guess, some of the data set here. So we have airplane is one of the classes. I like airplanes. go with that. So airplane is one class, and then automobile. Who doesn't like automobile? So let's do that. Right, an automobile is going to be class 1. Right, but there are more. So there are more certainly, and we'll just have to pick them. All right. So for this one, actually, it used to be also when I was in school that whenever we wanted to do anything to do with image processing, we had to use something called MATLAB. Any of you ever used MATLAB? Yeah, so some of you. That's a class in engineering. It's a very well-established thing. It's still highly used, and so we would do because it's actually vectorized and matrix oriented. We used to use that. That has changed significantly over the years, right? And now basically everyone has their own. So TensorFlow has their own. PyTorch has their own. Everybody, right? So it has just become basically they took whatever MATLAB did, and it's now everyone has it efficiently. All right. So in our case, we're going to be using something called Torch Vision. All right. So let's go ahead and I'll write it over here, basically. So what you have to do is you should by now know how to install everything. So you either do conda install something, or in our case today, we're going to do pip install. Remember, you have to do this inside the environment that you're currently using. So the one we've been using. So pip install Torch Vision. All right. So that's probably not installed yet. So let me at this time run it. So I am in the PyTorch, so I'm going to do pip. You don't have to put sudo. So just do pip install Torch Vision. All right, so let's give it a second. All right, and we should be recording. So it's probably downloading a data set, I think. Is it doing the same thing for you guys? It's taking a while. Oh, there it is. All right, great. Yeah, I think it was downloading a data set. All right, so hopefully you got this. So it means it is successfully installed. So now we should have Torch Vision to play with. Question, yeah. All right, so now let's go ahead and just call the libraries basically. As you might imagine, we're going to call the same libraries that we've used before. So let's open up the script again. So the libraries, I'm going to import Torch. I'm going to obviously import NumPy as NP. I'm going to import image IO, import OS. Then from matplotlib, import pyplot as PLT, import torch.optim as optim, and import what we learned last week, torch.nn, torch.nn as NN. Now the new libraries that we're going to install today are both coming from Torch Vision. All right, so I'm going to do from Torch Vision import data sets. And then from Torch Vision, import so these two, right? So data sets, it's self-explanatory, right? What does that mean? It means that there's some data sets in it, right? So probably CIFAR10 is there or something, or there's some mechanism for getting that data. Sometimes the data set is so large that it doesn't make sense for it to be in the library. Now, transforms, what is that? So basically, if you think about it, everything that we do, right? Everything at the core of everything that we do in machine learning or deep learning is basically a function. It takes an input and it gives you an output. Would you agree? That's basically what's happening, right? So you have an input, goes through a function, you get an output. A function then basically becomes a mapping mechanism. You map something, an input to an output, right? And if you think about it, that's a transform, right? A transform is basically the same thing. You take some input, you change it somehow, you get an output, right? So at the end of the day, that, transforms are basically that. It's a mechanism for converting the data, right? Because that's at the core what we're doing in machine learning a lot of the time. So this will be pretty interesting. It'll be a little bit confusing, I suppose, in some of the things that we're going to do, but the scale of it is pretty powerful. Okay, using this we can basically say, I want to change every number to be +1 in my, million record data set. Well, instead of, iterating through the whole thing and trying to change it, all you have to do is create a transform that does it. And then when you load the data, apply the transform. Done. You don't even have to worry about it. Does that make sense? So these are a lot of new concepts, right? These are a lot of new ways of doing things. But it's good to, it adds, I guess what my point is that it adds to the things we have to learn, but at the end of the day, they're useful. All right, so the first thing we probably want to do is download the data set. All right, so let's do that. So this is going to download into your computer. So, be aware of that. So if you're using your laptops or whatever, it'll download to your laptops. If you're using Scholar, it'll download to Scholar itself. All right, so if you remember, so let me save this. If you remember, I have a directory in here, right, called data. You can see it here. So we're going to store, let's actually go in there, take a look. Right, and you can see this is where we stored the text file, some images, the folder of cats, and the wine quality CSV, right? So we had that in there before. Right now we're going to have CIFAR10 in here, okay? So let's go back out. All right, so let's go ahead and now, good question is, do we need to put in let's actually, let me go back to that. And let's create a folder, a subfolder in data. All right, so in here now, I'm going to create a subdirectory in data, and I'm going to call it CIFAR10 data. Let me make sure I get that right. Okay, so I've created the directory in there, CIFAR10 data, so I'm going to store the data in that. We can go back out and let's open up our script. Okay, so now we're going to proceed to download the data set, CIFAR10. So let's create a data path. Data path, data, right? And then / CIFAR10 data. Okay. All right. So now we're going to invoke data set. So if you remember from Torch Vision, we created this, we imported data set so then we can reference it. So we're going to say CIFAR10, which is going to be our new data set, right? Our object. Data sets dot, and there are many data sets in here. I encourage you to play with this. In fact, some of the homework assignments, maybe, I want you to not use CIFAR10, but something else. So build a neural net of this specifications with this data set. So if I want to make it easy for you, I'll probably just tell you to use the data sets. If I want to make it hard for you, I'll say get this data set from some website and fix the format so that it fits into your neural net. So here we're going to call CIFAR10. We need to specify the data path, which is there. Now, the way that we can do this, one of the ways that we can do this is we can directly just download the part of the data set that we want. So in this case, we may just want the training set versus the testing set, right? So, and we can always just print out the sizes, the shapes. Remember, that's a standard practice just to get a feel for what we're looking at. So in this case, to do that is actually pretty straightforward. I'm just going to say train equal true. You see that? If I say false, basically I'm implying that I want the test set, or what is usually referred to as the validation set here in this. Okay, so train equal true, comma, and then do we want to download it? Yes. So that's why we created this, the subfolder and data, so that we don't have to download it every time, right? We'll download it once to our computer. Right, and that's basically that one. We also want the CIFAR10 validation version. So that's going to be the other part. And that one is very similar. We'll just say datasets dot CIFAR10 and then data path, comma. Now, where it comes to train, here we're going to say false because we don't want the training one version. We want the validation one. So false. And then we're just going to say here download equal true. So we're going to end up with both of these, and that's just going to be the validation data set. Okay. So I usually like to use these. This is just me. I like to have a clear distinction of everything. So now the question that we might want to take a look at is, the first thing that you would do is print CIFAR10, right? It's going to be pretty big object, but we can take a look. We can get a feel for what it is. Is it a tensor? Is it just going to be like an object that it's going to tell us some things about it, right? Something like that. So I'm going to do print CIFAR10. CIFAR10, and let's just see what happens. All right, so at this point, we're going to go ahead and run this code and download the data set. Okay, I guess we haven't, we've run it before. All right, so let's do Python here. Okay. So I feel like Torch Vision is having a conflict with Matplotlib in the versioning, because it's not saying that it's not there. It's just, right? It sounds like it's saying there's some kind of a conflict. Did you guys get the same error as me? Yours worked? How about the rest of you? It's just me. Just hates me. Okay. All right. Okay. Yeah. All right. Let me see. Yeah. You know what? You know what I'm gonna do? I don't need Matplot right now. I'm just gonna comment it out. All right, so let me try this one. All right, good. So just comment it out. That's what, that's the beauty of Anaconda, right? You can always just switch to another version when you don't need something. So in this case, if we look at what happened here, it ran, I would say. We downloaded the data set. It was extracted to the data CIFAR10. Files, are there. And it gives a little bit of statistics, number of data points, 50,000. Root location, split train. Okay. We can run it again. And this time it only verifies it doesn't download anymore, as you can see. And that's pretty useful. So there's about 50,000 in the data set. All right. So we can go back to the script. All right, and we're going to take this out now. Data. Now, what else do we want to do? So at some point, we're going to obviously extract the images and convert them into a tensor, right? So that's really the plan at some point. But for now, let's think about what we might want to do. So it's kind of nice when you have an image data set to actually look at it, right? So it's actually nice to do that. So let's say we want to see some information about CIFAR. So you guys, I encourage you to try different things. You should have a cheat sheet or something with a lot of functions and commands. So let's see. I want to get the length of CIFAR. Is that even possible? Printed. I'm going to print the length of CIFAR10 and also the length of CIFAR10 val. CIFAR10 val. Okay. All right, so let's go ahead and do that. As I said, when we have this, we kind of want to explore everything that we have available. You can see there 50,000 and 10,000. That immediately tells us, okay, great. We have 10,000 images, right? Sorry, we have 50,000 images for training. We have 10,000 images for testing. Does that make sense? That's why the total is 60,000. So it's accounted for. So that's great. All right, so let's think about something else. So let's see if we can't look at an image. All right, so we're gonna print, let's say, one image. So there are 10,000 images, right? So we can extract one image, any image, 89, let's say. Out of zero, from 0 to probably 49,999, we can extract images. So let's extract image 89. Every image, the way that CIFAR is made, will have a corresponding, the image obviously, which is 32 by 32, or should be, and the label, which will be probably, whatever it is for that class. Once we have that, we want to print it out. So I'm going to do print ng, and also print the label itself. All right, so let's go ahead and do that. Control X. Okay, probably have a typo. Oh yeah, that's right. CIFAR10. There we go. So we can see that the label is 4, whatever that is, right? The label is 4. And the image, we have some information. It's a pill, right? So the pill library, actually, there's in Python, right? So that kind of tells us something about the format. It tells us that it's an RGB image, so it's in color. And it tells us, the address and hex, and then it tells us the size, 32 by 32, okay? Now, to view this image, we're going to have to use matplotlib. So what I'm thinking of doing is conda remove matplotlib. Let's see if I can fix it that way. So I'm going to try to remove it and reinstall it. I'm not sure why. Not sure why I'm getting an error. Okay, so let's see now. I need to do that. Yeah, so it's not finding it. Mhm. Okay. So it took it this time, so hopefully it'll work. All right. Right. So no one had this problem, right? With the matplot not working. It was just me. You had it. You had the error. All right. Did you see what I did then? Okay. Yeah. Just do the same, right? So you can see if I run it now, it's not giving me the error. So I basically removed it and then reinstalled it with pip instead of with conda. It seems to be a versioning issue or something. All right. So now that we have it, the reason why I'm doing this is I want to see the, right? So it's rewarding to physically see these images. So let's try. So I'm going to go ahead over here, and I'm going to do plt.imshow img, and then plt.show. Let's see if that allows us to see the image just so that we have a sense for it. Control X, Y. And there it is. Perfect. And what is it, by the way? You see what I was talking about? You know, even if it's only, it's 32 by 32, which is what machine learning can process, if, you know, very fast. It's very hard to tell what this is. I think it's a bird. Let's say it's a bird. Huh? A moose? Okay. Well, there you go. Moose. Yeah. So you guys, you know, you probably have better eyes than me. Let's just take a look at a few images. So imagine how hard it will be for the computer if we can't recognize what it is, right? But I encourage you, I'll just do a few. I encourage you guys to do this, play with it. So, you know, we can do like 10,000, right? Because there's 50,000. So let's try another one. All right, this one's even clearer. This is a bird of some kind. That's the beak, right? It's some kind of bird. And the class for this is 2, right? So the class is 2. Let's do one in the 30,000. So a lot of people, this is why a lot of people will go as high as, you know, 250 by 250, 300 by 300, because they want to see what they're, you know, at least have a sense that it's clear for a human than frog. I don't know. Frog. A frog, right? So all these seem to be animals. I was looking for that airplane, buzz, and not seeing it. Yeah. Let's try one more, and then we'll give up. Let's do 15,000. Dog, definitely a dog, right? All right, so this one, at least for the machine learning algorithm, there's a face here for sure, a couple of eyes, nose, legs, a tail, I think. So, you know, that, you know, it's something, some pattern is there. All right, anyway, So let's, so we're, that was fun. So let's continue now. So let's go back to the code. And we can disable this part because we don't need to look at them. But now at least we have a feeling for the images. All right, and so now the next question is, what do we want to do? So before, if you remember, you have to take, the data set, convert it into a tensor, right? That was the idea, right? However, as I was saying to you, a more efficient way might be that whenever you create the data set, you automatically apply to it a whole bunch of transforms, especially when you're dealing with images. Let's say that you want to reduce the size of the images, right? But you also want to make them tensors, but you also want to normalize them, and you also want to do a whole bunch of operations, right? So then there's the transforms mechanism, which is something that is just in one line, you'll apply a whole bunch of different transforms to the image. That's kind of the idea. And so that might be a little bit complex, but that's what we're gonna, try to get a feel for. So let's go ahead and do that. So I'll put this under the heading, transforms. There's even nowadays a deep learning algorithm called the transformer, right? So it's it's basically the same idea. It's modifying. That's really what deep learning is. At the end of the day, deep learning algorithms are what are called universal function approximators, right? And so that's basically it, right? So they can approximate it. So let's go ahead and first of all, let's look at the transforms object. So let's do a print. And let's provide a directory listing, if you will, of what's in the transforms object. So if you look, the transforms object is this one over here that we got from Torch Vision. So you can see, because we're dealing with images, you want to apply a whole bunch of different transformation to the images. So we're going to do print dir transforms. Let's run that. Right, and you can see here, this is a list of all the different transformations that are available in Torch Vision. So you have auto augment policy, center crop. So, crops around the center, color jitter, compose, convert image, data type, 5 crop, Gaussian blur. So it used to be that before deep learning, people would spend years just creating filters for images, right? That literally deep learning, how they say that automation is going to displace people and their jobs, that a lot of the time that even happened in AI itself, right? And in the fact that it used to be a career of people in data science, machine learning, they would just create filters, image processing. They would create a filter for this and a filter for that, and apply it to the images, and that was their job. And deep learning came and it kind of displaced them, because now deep learning can certainly figure out the filters on its own, right? So all you have to tell it is, here's the inputs, here's the classes, figure it out. And that's actually the CNN, convolutional neural networks. But for many years, this was, when you see Gaussian blur, this was like the classic example. You would go to an image processing class, you would learn, okay, what is the Gaussian blur? Take a pixel, look at all the pixels around it, average it, that kind of thing. So that has definitely changed quite a bit over the years. Grayscale, interpolation, lambda is, for those of you that, CS students, you probably have seen this before. Lambda transformations and all that. Linear transformation, normalization, pill to tensor, right? Because the images are in pill data type, natively for Python, but then you want to convert them to tensor. We'll be converting to tensor, obviously. Padding, random adjust sharpness, right? That's another transform. Random affine, right? So that's another one. Random apply, random auto contrast, random choice, random crop, random equalize, random erasing, random grayscale. A lot of these, I think, have to do with noise, either denoising or adding noise. Random grayscale, random horizontal flip, random invert, random order, random perspective, random posterize, random resize crop, random rotation, size crop, solarize, vertical flip, resize scale, 10 crop to pill image to tensor. And then you have these additional built-in functions here. And transforms over here. All right, so as you can see, there's basically a lot of ways of modifying, basically, if you will, filtering the images in some way. What we want to do is we want to explore some of these, right? So that we can convert our images, first of all, to a tensor without having to go into too much trouble, right? So we're going to look at that. Additionally, we'll probably use the transforms for normalization as well. We're going to see yet another scheme of normalized data. Okay, yet another one. Okay, so let's proceed. We looked at these. Are there any questions so far, by the way? All right, so we're going to spend a lot of time today just on the data set, I think. Actually, the modeling part, you already know, right? So you already did simple neural net. So I think hopefully that one will come faster. But the data set, this is our first big data set for real. And so we should spend some time on it. All right, so let's go ahead now and open up the script. So that's the transforms. We can comment this one out because we don't necessarily need it anymore. All right, so basically we're going to use one of these called 2Tensor. So 2Tensor, which basically converts NumPy arrays or pill images. That's a format, right? Pill images to tensor. So what's important here is that our dataset CIFAR10, we saw previously that it gave us the images in pill format. So the 2Tensor function will convert NumPy arrays or pill images to tensor. And very importantly, it does it with correct dimensions. Remember that the dimensions that PyTorch needs are channel by height by width. But remember that currently all the images are height by width by channel. So we're gonna we did this last week where we permuted something. So we're gonna do the same, but this time around with the transform itself. So that's what we're gonna do now. All right. So first of all, let's just see an example of this. So let's create an object, 2Tensor, which is going to be basically a transforms. So from the transforms object, we're going to grab the 2Tensor function. You guys see that? So now we have it and we can reference it. So now I'm going to say img, but underscore t to indicate that it's now a tensor. And we're going to basically transform it. So all we have to do is say 2Tensor, and we plug in here our pill image. Does this make sense? So now it should be a tensor, which means that we have shapes now and everything, as we have seen many times before. So I'm just going to do print, and I'm going to do image underscore t for tensor dot shape. Right, and now when I print this out, it should have the dimensions. What would be the expected dimensions for this one? 3 by 32 by 32, right? Remember that's, so let's see if that's the case. And it is, right? So it's now a torch object size 3, RGB, height 32 by 32, height and width. Okay, and we've seen the image already. And now let's proceed. All right, so we have our image here. Now the trick is that we want to transfer basically this transform directly as we as we read the data, so that because here we only applied it to basically one image, right? Our image, whatever it was, 99. So if you look, we applied it to IMG, and IMG was just IMG 15,089. So one image, but we want to actually, we need for the whole data set to be tensors, right? So what we can do is, when we did this over here, this one thing here, we can actually pass to it the transform itself. You see that? And that's what makes this really handy, because we don't even have to worry about making it a tensor. It will already be a tensor for us. All right, and so that's the beauty of this transforms tool. So let's go ahead. Let's add a new line here. So let's just say here, the transforms can be passed directly to the entire data set. Okay, so we're going to pass it directly. So what do I mean by that? Basically now, if we had called our data set CIFAR10, now we're going to call it tensor underscore CIFAR10. You see that? And so that way, this one will contain the same data, but as tensors themselves. So let's go ahead and do the same. So let's do data sets. So if you think about it, it's quite intuitive, right? So we're going to do CIFAR10. And then we're going to do data path again, comma. We want the train set, so that's true. We want to download. You can say true or false. It shouldn't matter. It'll check. And now here comes the new part. So let's move. We need more space. Let's add over here a new parameter called transform equal, and this will be equal to the transforms, right, object or module that we already referenced, and from it we want the two tensor function. You guys see that? And just by doing this, what this implies is that it will apply it to everything, because the dataset CIFAR10 object has this built in. Now, keep in mind, this only applies when you're using datasets, right? Not to every single thing. If you have, let's say that you have your data from a text file, right, and you bring it in, you'll have to do the transformation much like you did over here. Does this make sense? Any questions so far? All right, good. So that's the data set. So now let's, once we have it, it'll print it. So let's say now these are tensors. Okay. And so we're going to print out some things. So now we're going to print out again. We're going to get an image from this tensor. So let's do from tensor, or from this data set called tensor CIFAR10, let's get object 99. And we're going to assign it to, remember it returns the label, so img tensor comma label. Okay. Oops, img t. Okay. And now we can look at the shape, the data type. So let's do print type imgt. Obviously the shape img underscore t dot shape. And let's just see print img t dot type. All right, so let's take a look at those. These three. All right, so let's try it out. Okay, great. So you can see it says it's a tensor, right? It says it's a tensor, so that's converted. It said the size is 3 by 32 by 32, so that's correct too. And it's of type float 32, right? So you can see that here. It is of type float 32. All right. Any questions? Make sense? All right, great. All right, so now that we have that, let's see what else we can do. Now, if we want to look at this image again, we have to permute it back. So remember, it is now 3 by 32 by 32. But if we want to view it, it has to be 32 by 32 by 3. So we have to kind of permute this back. So let's do that. I'm going to scroll down here. And I'm going to do, let's say, to show images, we need to permute back so e.g. from channel height width to height width channel. Okay, so we just have to permute it again. Because it's a tensor, that should be more. We can use the permute mechanism in tensors, so we could try plt dot imshow imgt dot permute, which is the function we saw last Monday. And here we just have to say it's currently channel height width, right? So the 0, which is the first index, goes last. So it should be like that. You guys see that? 1, 2, 0. We move this 0. Currently, the 0 would be like here, right? But we're moving it to be over here. All right, that changes the order, and imshow should be able to process that. So then we do plt.show. And now let's see if we can view the image. And there it is. What is that? It's a car, right? And there you go. Any questions? All right. So we view the car. Perfect. So now we're going to disable this one, but we know that we can also view tensors. We just have to permute them a little bit. All right, the next step that we want to do. So we know that we can apply transforms to the data set directly, right? And we know that tensor CIFAR10 is actually already tensors. So the data set, this is probably going to be the data set that we want to use to build our model, right? To build our deep learning model. So we have to think of the next steps in the process. So we viewed the tensors. So what else can we do? So image T is a tensor of 32 by 32, right? What if we want to see the values in there, right? So some of the data in there. So for instance, let's say the minimum and the maximum data in there. So let's take a look at that. So I'm going to do here print image underscore T dot min, and also print image underscore T dot max. All right, so those are functions that we can apply because it's a tensor. So we just want to look at what that will give us. So let's go ahead and run that. And 0 and 1. So let's actually, let's take a look at this. Print. So there's the function 2numpy. Do you guys remember that function? Anyone remember the actual syntax for it? Has it underscore? Yeah, I'm looking it up. Yeah, I don't remember either. But it's a handy one because I want to see the data now. So there should be. I think it's just numpy actually. So let's try that. Right. So let's try this. Just okay. All right. So there's the data. Let's see. So I was able to print it with both the tensor, and the numpy. And if you look, the values all seem to be within 0 and 1, right? Do you guys agree? So as far as I can tell, so it's correct, right? It seems like the min and the maximum are probably 0 and 1. Got it, guys? Any questions? Nope. All right, great. So that's PIL for you. PIL, remember, gave you that. That's the data that we got. So I will argue it's correct, right? So the min and the max that we got seem to be correct. All right, so this seems to be a good stopping point. Okay, it's 3:20. So let's stop here for, let's take our 10-minute break, and then we will come back at 3:30. So I'll take a 10-minute break as well, and I'll start collecting the video at this time.